The question says for which of the following molecules the dipole moment is non-zero. Means which molecule is polar by nature. Dipole moment is non-zero. Always keep in mind dipole moment is directly proportional to electronegativity difference between the atoms. Higher the electronegativity difference between the atom, higher is the dipole moment. Okay, if electronegativity difference is 0, then dipole moment will also be 0. Another point, if the central element is having lone pair in a molecular compound, its dipole moment will always be non-zero. Okay, its dipole moment will always be non-zero. Pay attention carefully. You can see benzene, 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 benzene. Based on the benzene, we cannot determine the dipole moment because similarity is there. Now we have electronegativity difference. Always keep in mind dipole moment is directly proportional to electronegativity difference. Higher is the electronegativity difference, higher is the dipole moment. Okay, this is carbon, this is carbon. Okay, if you find the difference, Cl is more electronegative than carbon, this is the dipole moment we have. But in this case also you can see Cl is more electronegative than carbon, dipole moment. When these two arrows are moving opposite direction, in this case they will cancel out each other. Even if the arrows are coming like this, dipole moment will be 0. Okay, dipole moment will be 0. So in this case dipole moment is 0. Okay, I talk about this one. This compound is little bit interesting. Why? Because you can see, let me try it here also. This is what we have, Cl, and in this case it is C. Now question arises here, I should draw C triple bond N, or I should draw C triple bond N, or I should draw C triple bond N is there, like this. Okay, so in this case we can determine the geometry. You can see if I mention this is what C triple bond N is there. In this case carbon is forming how many sigma bond? 2 sigma bond. Then it is having hybridization sp, and then geometry will be what? Linear. Sp hybridization means regular geometry or linear. Carbon does not have any lone pair. So linear in the sense we have to draw like this. Clear? Linear. Well, in this case if you see here we have the dipole moment, but in this case it is supposed to be dipole moment 0 because this is what carbon, this is also carbon. But experimentally it has been determined the dipole moment, the magnitude of the dipole moment, and here also they will cancel out each other and so it will have 0 dipole moment. Remember, anyway it is going to be carbon carbon, it is going to be 0, but nitrogen is also there and it is forming 3 bonds, means it is pulling 3 electrons from the carbon. 3 electrons, electron flow is towards nitrogen. Experimentally it is determined this portion dipole moment is equal to this portion dipole moment, and they cancel out each other. That's why dipole moment overall is taken, resultant dipole moment is taken 0. Okay, in this case it looks like a dipole moment towards a carbon. This is carbon, this is also carbon. Oxygen is more electronegative than carbon, it will pull electron density. Dipole moment will go like this, dipole moment will go like this. Here also it will go like this, and they will cancel out. No, it is not so. Why? Because the central element oxygen is having a lone pair. If we talk about water molecule, let's say in this case oxygen is forming how many bonds? 2 bonds are there. This is the geometry we have. Lone pair is there, lone pair. Why? Because in this case 2 sigma bond and 2 lone pair are there for the central element oxygen, and 4 sigma bond is there. And then hybridization is your sp3. Then we get tetrahedral geometry. If we place these 2 lone pair, then it is having bent shape. Bent shape is there. V shape, angular shape is there. So similarly, if we draw the structure for this para, we can see para dihydroxy benzene is there. Then it will be H is there, and this is O, and it will be H is there, like this. Bent shape will be there. Bent. V shape will be there. V shape. So in this case, if you mention like this, they will not cancel out each other. Dipole moment will be there. Dipole moment. And we can say dipole moment will not be equal to 0. Okay, dipole moment will not be equal to 0. Same is the case here also. You can see we have let me use the different thing. This is O and it is H, and this is your oxygen. No, sorry, sulfur is there. There is no problem. Sulfur is there, and this is H is there. Here we have the dipole moment. In this case, also dipole moment. Anyway, sulfur is more electronegative than hydrogen. Okay. This dipole moment is not equal to this dipole moment because electronegativity difference is there. Okay, oxygen is more electronegative than sulfur, but polarity is there. 100% cancellation is not there. Here also, anyway, these arrows are going like this. If they are coming opposite to each other, they can cancel like this. We have, they are going moving away from each other, but they are having same magnitude of the dipole moment. In this case, dipole moment is 0, but in this case also they are not coming opposite to each other. Even if they are coming opposite to each other, dipole moment will not be 0 because in this case more electronegativity difference. Higher the electronegativity difference, higher the dipole moment. In this case, less electronegativity difference, it will be like this. So this dipole moment will be dominating this one. In this case, it will be non-zero because 100% dipole moment cancellation will not be there. Okay, so you can see third and fourth having non-zero dipole moment. Okay, you should be careful with the second one. In this case, it has a 0 dipole moment, hence we have option D is correct. If you like this video, please share and subscribe to the channel.